All right, this is 110. We're going to use the debugger on code we wrote in assembly. So we have hello world. Let's take a look at that. It's hello.asm. All right, so this just has a message, hello world, and a length pointer, which calculates the length of it. There's no carriage return line feed at the end even, and all it's going to do is call function call one, syscall1, which will print it out and then close. This is the very simplest hello world to get you started. All right. And now we're going to debug it and take a look at the instructions, and we're going to try different formats. So let's debug it here with gdb -q hello. Okay. And now it's at start. I think I can disassemble start. Yep. Underscore start is always there. So here's the code, and I don't like the stupid colors, so let me set style enabled off. All right, and now I can disassemble. All right, and I'll make this a little higher to make sure it's caught by the streaming and stuff. All right, so here we are. This puts C into EDX. Notice you can always tell which format it is. This is the format that puts the source on the left and the destination on the right, which is, I think, AT&T format. Now, if we want Intel format, it is set disassembly flavor Intel. And now when you disassemble something, you're going to get the other one where it's source destination. Those are the two ways to do it. So this is going to put C into EDX. This is going to put an address in there. So this is going to be the counter for the length of the string, I imagine. This is going to be the pointer to the data, and this is going to be the syscall number, which is 1 to write, and here's the 4 in EAX, which I forget what that is, and then you call this to print it out. Probably 4 is right. Anyway, let's go back to here and see. Yeah, it's 4 is to write, and 1 is the device to write to, standard out, I think. Anyway, that's what happens. And you can see the code here is now going to look like my example there. Let me put the two next to each other. So this is the code I wrote in, and here it is pretty much doing it. The only difference is instead of using this variable len, it goes and evaluates the variable len and fills it in literally here. And instead of having an alphabetic description of message, it has a pointer to the data section where message is. And if I do info proc mappings, I'll be able to see what that A1000 is. All right, and I can't do it because the program is not running yet, but I can start the program with start I. That will start it and not do and put a breakpoint on the first instruction. So it doesn't do anything yet, but it gets started. Now I can do info proc mappings, and now you can see the code segments. And so here's the header segment at 4A1000. Here is the, and notice the permissions, read but not writable, executable. And here is the text section that contains code. And so I guess what's happened, this is not the header section, this is the data section, because that was the address here. So that seems to be where it stored the data. This is the data section, and this is the text section. And notice, by the way, that it's violating that security principle we were talking about in the lecture. It's got write and execute both turned on. So that's a little unprofessional, and that, I suppose, is a consequence of NASM. The assembler we used to compile this allocated memory in an unsafe way. There probably is some later version of that assembler or some kind of compiler flag we could have used to limit this. But the text section is writable, which means I could make self-modifying code here, which is considered very unprofessional. You're not supposed to do it these days. Anyway, here's the stack. And so I can look at this area, 804A1000. If I look at some data there, like 4X at that address, then I'll see some data, and this is ASCII printed characters, so it'd be easier to observe it as characters, like 12C, and there you see it spelling out HELLO, or you can observe it as strings. If I make this 2 strings, then I'll see hello world, and then a blank string. So, this is all the same memory viewed in different ways. All right, and we did Intel format. And now we can run breakpoints and see what it does. If we do break start +10, let's do disassemble start again to get oriented. There we are. All right. So here I'm going to move EBX1. If I can put a breakpoint. I can either specifically enter this address, or I can use start plus 10, which is easier. So it's break start plus 10. Now if I run, it'll stop it. I run it, start from the beginning. It'll go to that point. Now if I disassemble the code again, it will add this arrow to show me where I am. So I'm here. I'm about to move EBX1. So if I do print $EBX to see what's in there, right now it's 0. But if I do one more instruction with next I, it moves forward to this instruction. Now EBX should contain 1, and it does. The next one's going to put EAX4. So if I print EAX, it's 0. But if I go one more step forward, now it will be 4. So you can see what it does. All right. All right. And we saw the memory segments, and we saw how the data is stored. All right. And then there's a few challenges here where you just have to examine this code and find out which extra assembly instructions are causing problems. So it just gives you a little practice navigating the disassembler. And that's all there is to this one. So I'm going to stop this recording.